So rose engine lathes. Merkel's rose engines started in like 1780, so they've been around for a long time. Rose engines were used to produce a complex background and border patterns for the earliest postage stamps. So they would engrave on a metal plate, ink it, and put it on the stamps. Now back in 1780, it was pretty hard to reproduce that. That was their way of, they couldn't be forged. Rose engine lathes is a special kind of geometric lathe. The headstock rocks back and forth in a rocking motion or slides along the spindle axis in a pumping motion. A rosette or cam-like pattern mounted on the spindle is controlled by moving against a cam faller, and I'll go through all this and show you, while the lathe spindle rotates. Rose engine work came from can make flower pattern as well as convolute, symmetrical, multi-lobe geometric patterns. The patterns it produces are similar to that of a spirograph in metal or wood, and no other ornamental lathe can do these rose patterns. The decoration produced by a rose engine lathe is called guillouche. It's sometimes confused with jewel finishes. Engine turning on a much cheaper process, making swirl patterns in metal by rotating a peg with an abrasive on it, which is repeatedly applied to the surface, making patterns of overlapping patterns. The patterns of the United Kingdom's first postage stamps, known as line engraving series, including the penny black of 1840, were based on rose engine patterns. The die was prepared, printing plates, and partially created by means of the rose engine, which produced a complicated pattern on several separate pieces of metal. This pattern made the stamps difficult to forge, known in 1852 as the Perkin-Bacon Company. Carl Fabergé used the rose engine lathe to create his signature decoration, guillouche enameled, for his infamous and famous eggs created for the Tsar Alexander III of Russia. The rose engine cut a series of parallel lines into metal surfaces onto which enamel was applied. So here's an example of one of the early ones. You can see it was a treadle lathe. Not too much in the rocking part of it at this time. And if we go to the next slide. So here you see now they have an overhead drive with running some of the tools down here, but it's still a pedal that rotates the spindle. Okay? Getting into probably, this is getting closer to the 19th century. They've incorporated overhead electric drives that both run the spindle and the tools that do the cutting. And you'll see down here is the hand crane that they could use, and it's geared very, very slow. So this thing is barely moving, like they're talking maybe 2 or 3 RPM that rotates and is cutting. Okay, and the next one. Now this here is in 1980, roughly. John McGill, who was a member of the AW, created what they call the MDF rose engine. And this was made out of a sheet of MDF with a few basic parts, so the average person could afford to build these. Those early lathes were like hundreds of thousands of dollars, and you'll see they get more complicated. Next one, Ryan, please. Here late in, say, 2000, a fellow by the name of Rich Colvin started adding electronics, stepper motors. It's not CNC, because it still has to be done manually, but the rotation is done by stepper motors and electronics. Okay, next one. And the Mandela rose engine. So this is one that's commercially produced. They're in that, few $1,000 range. And you can see here, these are what they call the rosettes. And you have a spindle, and there's your head, where your headstock would mount. Okay, next. Now this is more of what I have here. You can see here, it's a horizontal with a fly cutter on it. And that fly cutter spins and is very, very sharp. I'm using 1/8" high-speed steel metal lathe cutters, and I grind them to a point. That's what gives me the fine, fine cuts. On this one here, they're using it as, I guess like you'd say, like a spindle or like a router. And again, there's all kinds of different cutters you can incorporate into that, from the little 1/8 up to router bits. Down here it just shows another example of that. And here you can cut either on the end or on the side. And that's just a little closer of that fly cutter. Okay, now this one is eccentric, so that cutter there is off center. It's turning circles that are produced in here, and then they're indexed to rotate slowly and cut that eccentric pattern. And this is just a slide showing a close-up of those rosettes. On those lathes, they're mounted all on one spindle so they can incorporate more than one rosette to make different patterns. Mine is a basic model. I have one rosette at a time. Next. And this just shows a little bit of the indexing that can be done. I have a light indexing plate. We'll get into that a little more, but they can be indexed on an infinite almost number of degrees. Okay, next. And this just shows something that John McGill would use on his. Usually they were Corian or acrylic or a plastic. And by using these different holes, you can phase your pattern. So you can cut, let's say, on 12 degrees all the way around, rotate it, and it would be half of that. So instead of cutting on 0 and 3, you'd be cutting on 1.5, 4.5. You can phase that around. Okay? And this is just showing a few of the rosettes that the Mandela Rose Engine uses in their commercial sales. So, you know, you can have any number of patterns. I've seen them actually where they have 3, and they're making like a triangle bowl, but it would be really slow cutting because you can't do most of the cutting on a conventional lathe like I do here. I'll get my basic shape, and then I mount it on the Rose Engine lathe, and it cuts the pattern. Okay? And this is showing when we talked about the front pumping. So these lobes are on the front surface, and as that turns, it pushes the headstock in and out. Now, I have this one, it works, but I'm not happy with it, so I'm always working, upgrading, and trying different things on it. But it will cut a wave on your bowl this way, creating waves around the outside. This is one of the ones that I did. So it'll cut these wave patterns, but I wasn't happy with the pattern, but that's what it does. And then this is oval turning. So as the chuck rotates, there's gears or a cam inside that moves that from side to side. So that's how they get to cut an oval pattern like this. Okay. And okay, this is just some of the patterns that I've found on the internet that people have done commercially, the professionals, let's call them. Next one. Right. We'll just run through this quick. So John Sawyer is one of the fellows that's very famous. And you can see by incorporating, you know, different layers of wood, doing squares, you know, these long cylinder boxes, the tops, he does fabulous work. This one here is done with a combination of a metal lathe, a wood lathe, and the Rose Engine. He machines the walnut and makes it within like 1/1000th of an inch inside. It's got to be so precise. Then he turns this fake ivory, and it's got to fit in so that it's just a slip fit, just enough that the glue will hold it. And then the third one, and I can't remember this, I believe is pink ivory. It's a manufactured product, but I can't say that for sure by memory. So then he puts it on the Rose Engine and cuts that pattern in. But those 3 pieces are like just a few thousandths of an inch thick, and they slide into each other.
Is that Bill Owens?
This one, I believe, was Bill's, yes. Yeah. And then this one here, and I have not even got close to that, but as it's turning, it's pumping, but also there's a mechanism that sweeps it in a curve, and that's how they get that curve pattern in there. And again, that's over my head for now. Okay, and I think that's the last one. So I'm going to hook up a blank here, and we'll do a quick turning. It's going to be a little bit noisy because it is a router type material. So what I've got here, maple is one of the best. I guess I should run through a few of these things first. So here we have our spindle, and it has just a 1 inch by 8 threads, standard. On the back side is our rosette, and this is your pumping mechanism. This here is a bearing that they call the rubber, and then there's just a light spring here that keeps tension on that. My cross slide, I can move this in and out, back and forth by just a few thousandths of an inch. I have a horizontal cutting frame with that little cutter on it, and then I have a variable speed to run this motor, and also variable speed to run and I can change that speed. We always run at very, very low speed. You know, that's about where I want to cut. Okay. This stopper here adjusts the magnitude. So if I want to keep that rosette from going all the way in and out, I can move this in or out and adjust how far it will cut in depth. Okay. So what I've got here is just a 1-inch nut epoxied into a hardwood block, and then I hot glue on a piece of maple. Now the hardwoods are the best. If you try and do something like oak, even walnut, unless it stabilizes, it just wants to tear the grain. So they don't work that well. Ebony is probably the one that they use the most, and some acrylics, but ebony is out of my price range anyway. So now by cutting on either the left or the right, I can also change the pattern. I'm just going to cut one in this example here. I'm working off the back side here that I'm not usually on, so forgive me. Can you see that, Brian, or which way do you want to
Yeah, the other way. Yeah, that's good.
We're starting to get a little bit of cutting there now. It is slow, so like I said, it's kind of like watching paint dry, but give me a minute and you'll start to see what happens here. Speed, like, you know, most people say on a router you got to have it cranked right up. Speed doesn't always. Sometimes it starts to tear, so it's something I've learned just to kind of play around with my speed. Can you see a shot of that now? We're starting to get the color coming through.
Not a bad connection there.
You're just advancing it slow.
All I'm doing is moving that in a few thousandths on each rotation, yeah? Well, what happened there? All of a sudden there's wood coming through. I don't know if you can see, this isn't trick wood. What I did was, on that maple, I turned a circle inside, glued a piece of walnut in, and I glued a piece of maple over top, just thin veneer. And you'll see that pattern starts to come now with the walnut. And I could go back and forth to make longer patterns in it, but you can see how that pattern is developed now. That's okay.
No, it shows. There it is.
So part of, for me, is making the tool. I enjoy that kind of thing, but
Because you're plugged into the same
it,
outlet, right?
What's this?
Is the same outlet? Is that what's?
No, I got that from
are
over
we
there.
okay to pass this around, or I don't want
Oh,
to?
for
Yeah.
sure.
Okay.
Yeah.
Yep.
There's a spray bottle here if anybody wants to.
Sanitizer there.
sanitizer.
It's going to take me a minute, and I'm going to switch to a different cutter and just show you a different pattern. But is there any questions? Anybody have something?
Sheldon, did you wake up one morning and have a nightmare or something?
No, I think it's called too much time on my hands.
Wow, well done.
I spend a lot of time, like everybody does, or most people, a lot of people do, is looking at the internet and, you know, different things. And I ran across this, and I thought, oh gee, that looks kind of like it might be fun. So I slowly started on it. Most of this is scrap, not really scrap, but things that I had lying around the shop or that I could acquire very simply.
The next question, Sheldon, what time period are we talking here? How many years have you been doing this?
I think about probably working on it for about 3 years, 4 years.
Oh, wow.
But again, you know, it sits for.
Can you visualize the end result when you start?
Yes, I can.
Okay.
So by mounting this flat, they call it a paper chuck. I didn't bring a piece of paper, but I can clip a paper onto this, and then I put my pencil on where the cutter goes, and it'll draw the pattern on the face only. I haven't figured out how to do it on the side grain. Like if we're doing this edge of a bowl, I haven't figured that out yet. But I can do it on the face. This just goes in and out and follows across the grain. Okay?
So, Sheldon, other than, well, or with the machinist table, how much have you spent?
I think probably around $400.
Okay.
So it's not big money. Well, no, 500. I built the table here for this, but yeah, it's not tremendous dollars.
And your rosettes, where do you get those?
The rosettes, the first few that I did, I actually did myself. I have an indexing machine, so it'll do 360 degrees.
Right.
And I set it on my router table and I just ran it across. So all I could do were these flat patterns.
Okay.
We'll send a couple of these around. Now you'll notice that there's a cross line across here, and I'll explain that in a minute.
Is that just Lexan, or would you make?
That's just acrylic, yes. So then my neighbor said, gee, that's pretty neat. We have a CNC machine at work. So he started cutting out the fancy rosettes that were based off the Mandela one. And he was able just to take a picture, put it on their laser, cut it out way quicker. All right, so we're going to do this with the router.
Way more accurate.
And way more accurate, yes. Well, the first one's worked. That just was not real accurate.
And can a person buy those? Like if we don't have a neighbor that has a CNC?
Sorry, what's that?
Can a person buy those?
Yes. So on that Mandela, there is a website.
Yeah, you can just go there and order them.
Yes,
Oh,
that's right. Okay, so what I'm doing now is just I have a router mounted, or it's the RotoZip.
Sheldon, can you just turn it sideways? The other way?
Or which way? This way?
Yeah, I think so. Yeah.
Still can't see it, eh?
Yeah, that's better. There we go.
So the cutter that I'm using is a 1/8 single flute, and that's just off of a CNC router. So there you can see, all I did was took a piece of maple and sprayed it with black lacquer. So I've gone 10/1000ths of an inch in. Now if I was using it for an ornament or something, once I'm done, I would just lightly sand the surface and then spray it with clear lacquer. I'm going to back my cutter out, and I'm going to move it in 100, 200, 300. Alright, I moved it out. Again, that's maybe 15,000 of an inch.
So that surface has to be really parallel.
Yes, I think O'Dale was at my place, and I said I'm having trouble because it would cut one side but not the other one. I had to go quite deep. And so here, just in the last month or so, I thought, well, you know, everything seems good. I put a dial indicator on and couldn't figure out why. But these blocks, if you machine them on your regular lathe, and then put them onto here, they can be out that like 5/10 thousandths. So what I do now is I put a router bit in here, I take the face off the block and the piece I'm machining, and I'm getting those cuts that are just about right on. So now I've switched to the other side, and we'll just see if that pattern changes much. So you can see that that changed just by using the other side.
Yeah, it looks more like a sawtooth now.
Yeah, yeah. Now I was getting smaller, so the pattern changes because you're smaller, but it does change it. Send that around. I think I've covered most of what I had. I talked about, you know, the pumping action, so I can change this and put it on, and I have another rubber that goes on, and then I just loosen the cam off, and this slides in and out. On the back of this lathe, and if you notice that all those rosettes, when they came around, I have a degree wheel on here marked 0 and 180. By loosening these, I can change it any number of degrees one side or the other. So if you want to make overlapping patterns, or like that one was in the slide, he would cut one and then move it. So if you were cutting 12, you would move it 15 degrees, and it would cut in the middle of those two. Any other questions? Okay, well, that's all I had then. There's examples up here. Feel free to come up and have a look. I can pass them around, but if you want to just come around, you can see. And then if you have any more questions, just grab me and I'll explain.
Do you want to just hold up a couple and we can...
Sure. So here's an example of a bowl that I did. And thanks, Dale, I remembered to try and get the grain as close to the center as I could. But again, I just used that little cutter, made a circumference. Here's a number of different, different patterns that I've made, just using different rosettes, and maybe most of them were done with the fly cutter. There's a bowl that I did with the outside rim,
Wow.
just getting a different pattern on it. These little boxes I've been playing around with, and trying to do them on the inside as well. The last one that I worked on was, I saw it on one of the videos, is doing a bowl on the inside. And then it has a pattern going around the outside and at the back.
How many hours do you have into that?
You know, it's surprising because I can set the machine, walk over, do something else, let it run for, a couple rotations,
Great.
move it. So
It's not that bad.
it's not that bad, really. It time-wise it is, but
Yeah.
not actual working like you're standing at the lathe.
Yeah.
A few of these tops been making just for fun. And playing with colors, as we've been talking about. These were, well, it's just Baltic birch. And I lacquer them first. Give them a real good coat, cut them. And then I used acrylic paints. And once the acrylic paints are dry, I can touch just on a disc sander, just barely touch it, and it'll sand the color off, leaving just the depression.
Sheldon,
Yes.
I know on the inside of the bowl,
Yeah.
did you use a ball cutter?
No, it was still,
To do the,
it was still this fly cutter on this one. And I'm just going into the bowl this way, and it's just moving in and out. So as that's turning, it's just, it's spinning and just cutting a little bit of it.
Okay. I'll look at your cutters.
Yep.
And I know you said you get quite a bit from YouTube and the internet and stuff. Is there people that you use for inspiration or that people could look up and get?
Yeah, so I am a member of the American Association of Ornamental Turners, which is a subsidiary of AAW. And again, some of the fellows that I mentioned in the video, Bill Ohms, that Rich Colvin has dedicated a full web page, all kinds of information on rose engine turning. A lot of it is over my head, you know, because these guys are, most of these guys are engineers and stuff, and I'm not, I'm not at that level. I'm just having fun with it. There's a society of ornamental turners, and again, it's a private group, so you have to ask to be part of it. I haven't joined that one. And David Lindlow is a fellow who does a lot of research into the old lathes, restoring them, and they have set up, they call it the Plumber Foundation, just like plumber, but it's named after one of the society members. And they have a huge museum of all those old rose engine lathes, and a lot of them are like made out of brass, like you saw some of them, and they're highly precision, and they're hundreds of thousands of dollars now. So it's quite a unique thing. I just am having fun with it, just playing. So I haven't made anything serious with it yet. We had some horn, so I did a piece of elk antler, and it turned out exactly how I thought, other than in the antler I haven't figured out if you can bleach it or something, because you're getting the inside of the antler isn't true white. It's a lot of brown to it, but it was fun to turn. Other than that, that's about all I had. So I guess we'll...
Thanks so much, Sheldon.
All right.